Okay, so just as a sort of review of where we left off, we were talking about the same origin policy. So this is something that exists in your browser. And it exists for really two reasons. One of them has to do with cookies, and technically cookie policy and same origin are slightly different, but they end up being effectively the same. And it's basically going to make sure that your Facebook cookies don't get sent to Google and your Google cookies don't get sent to Facebook. And then it's also going to apply to JavaScript. Actually, any resource that gets loaded on a website, but JavaScript is the most important because it can do the most damage. If, for example, the script that you loaded from Google can read the data from the script that you loaded from Facebook or those types of things. Okay, so the same origin policy is going to try and enforce some isolation of different resources that coexist on a website, or different cookies that exist in the same cookie jar. Okay, it's basically a trade-off where you could have a very staunch policy where you try and isolate everything. That would be great for privacy. It would be great to know that resources aren't stepping on other resources or changing other resources. But then it just wouldn't be that great of a web. You couldn't do things like mash up different websites together, have like a widget from Facebook on your blog that Facebook is actually filling in, and those kinds of things. So there's a basic trade-off where developers want lots of functionality. They want to build cool websites and things like that, interactive websites, lots of scripting and those kinds of things. And then the sort of security people want, kind of privacy and integrity over the content of the page itself. So the same origin policy tries to strike this balance. It was made a long time ago before the web looked the way that it did. But it's still pretty sensible. But there are a few kind of breakdowns in what your mental model might be that lead to unexpected attacks. So there are attacks that you now know about, and as you take other courses, you'll learn more about the technical details of the attacks. They're like very common, like cross-site scripting and cross-site request forgery. But the reason that these became so prominent is because people's mental model of how things should work and how it actually worked were kind of out of sync. So I'll show you those two. Okay, this is also just review. It looks a little more complicated than it is. But this is just a reminder on how cookies work. So the idea is that you go to a server and say the first response that you get back from visiting that server can set a cookie. Okay, so a cookie is a key value pair, has expiration dates, some flags. We talked about it last class. The cookie's stored by your browser in your cookie jar. Okay, now let's say that the response is like index.html or some HTML file, and then that HTML file itself says, okay, great, you downloaded me, but I'm not complete. You need to go grab this image from here and this JavaScript from here and this CSF or this content layout file from somewhere else. And so what will happen is that one index.html file might load like 50 resources from a bunch of different websites. Okay, so all of these requests could be, some of them might go back to the same server, some of them might go to different servers. And in every case, what your browser does is it basically looks at the request, it decides where is it going, what's the origin or the domain that it's going to, and do I have a cookie that matches it? If I have a cookie that matches it, I'll add it into the request itself. So I'll put it in the header of the request. And so there might be more than one cookie that matches it. So for example, this website just set this cookie, so that would be one of the cookies that's returned when you go back to the server. Some servers may not have cookies. They might not use cookies. They might not set them. Some of them may have 1 cookie, 2 cookie, 5 cookies. It all depends. Okay. And the policy is basically saying, how does it decide whether a cookie in the cookie jar should be put into the request or not? So this is sort of a subset of the test, but these are the main things. So the first thing is the domain has to be exactly the same. Or when the cookie was set, it has the option of saying, match me to other domains as well according to some wildcard. So every subdomain of me or a super domain of me. So it will look at the domains and it will figure out if it matches. Then it will check the flags. So for example, did this request come over HTTPS? Was it launched by JavaScript? It may not include a cookie depending on what flags are set in those two cases. And And then cookies also have an expiration. So eventually they will expire, and then your browser will stop including them. As we talked about, whether the website deletes them, that's up to the website itself. Your browser can't control what a website does, but it will stop sending those cookies to the server itself. Yeah.
What was the example you gave us last time for cookies? The request matching flags.
Like, what does that look like in terms of wildcards? We can just pull it up. So for example, let's say we have a URL like encs.concordia.ca. That will only get sent to requests to that domain, that exact domain. So even if it's like users.encs.concordia.ca, it won't match. But what the cookie could do is it could say, instead of doing an exact match, I'll accept anything that's star.concordia.ca. So that sort of moved up a domain. This can change. So this could change to a bunch of different values. Or you can say any subdomain of me. So me plus any new subdomain of me will also match. And so the star here, is a wildcard.
Okay. So what's the difference now? Because there's a wildcard and then there's a flag. Request that much.
Yeah, and then the flags are two additional things that you can say. So one flag is called HTTP only. It says only send me if there's only send me if it's not going over JavaScript. So if JavaScript initializes it, don't send it. Otherwise, send it. And secure says only send it if the connection is secure. Yeah. And these they don't look like they're named kind of in a weird way, but you could have something that's over JavaScript and secure, or something that's not over JavaScript and not secure, etc. Like all four combinations are possible. Yeah. Other questions about this? Okay, and then if you ever want to look at your cookies, just open up a website. There's inspect element, and it will show you a list of all your cookies, the values, basically all the information, and you can see what gets set by an exact website. Okay, cookies are good and bad. So the web wouldn't work without cookies. For example, they're the thing that keeps you logged in. So you go to Gmail, you type in your password once, then you don't have to type in it again until you explicitly log out or close your browser window. And even then, you might not have to log in again if you set it to keep you logged in. So all that works because of cookies, and Google can recognize that you're the same person because you have a unique cookie value that's tied to your account that Google set. The other thing that cookies will allow is what you could do is you can embed content from another site, and it could actually kind of function on your site as well. So for example, if you had a news article, you could put a little Facebook. In this case, embeds may be the wrong word. We'll go through the differences, but you would have a frame. Facebook would populate that frame. And if the user that was reading your article was logged into Facebook, Facebook could know that this was Jeremy Clark, and they could actually fill it in with content that's relevant to me. Like, how many of my friends shared this story? If I want to share it on Facebook, I just click once, and then it automatically crosses over to Facebook. I could like it without ever leaving that website. So it would register that like on Facebook, but I wouldn't have to navigate over to Facebook. So these are things that also cookies allow. Because I'm logged into that website, then that can all happen seamlessly without any interaction, without requiring a password or anything like that. The issues with cookies are, this is a subset, but the two main ones are you can get tracked from site to site to site. So every time you load a resource from, say, Google, and like something like 80% of the top million sites have Google Web Tools or something like that enabled on them, Google can basically know every time you visit one of those sites because you send a cookie. And usually the cookie, or the actual request that the cookie gets appended to, that will be customized somehow to the site that you're coming from, so they'll sort of know exactly who you are. Now that's good for the website owner, because then Google can collect that data and tell the owner of the website some demographic information about you, but for you it's not necessarily good that you can be tracked across all these different sites. And then that's how you get like targeted advertisement where you're looking for boots on Hudson Bay Company, and then all of a sudden you go over to like reading Reddit or something like that, and you see an advertisement for those exact boots that you were looking at. So that's because there was some third party that was that tracked you on both of those two websites, and then they correlated those two pieces of information using cookies. The other thing is that if I can steal your cookie, then I can steal your session, so I can just log into you. It's almost as good as stealing your password. Your password will probably have a longer shelf life than your cookie, but it's effectively as effective as actually stealing your password itself. Yeah.
So the second feature, cross-site request, is it good or bad?
Cross-site requests are good. Yeah, so they allow, like I say, they allow some cross-site functionality. So they allow the modern web. The modern web would not work without these cross-site requests.
Will that result into cross-site scripting?
So there is something called cross-site request forgery. And so that's when cross-site requests go bad. And so I'll talk about that in a second. So in general, it's not a problem with cross-sites themselves. It's just understanding how they work. But yeah.
Okay, just to buttress what you said,
Yeah.
I encountered a similar problem today. And what the problem was, okay, I developed an API which is supposed to expose some functionality, and a client supposed to consume that API. And what happened was the API and the client was on different hosts. So the client was unable to consume the API on the browser. Though there are some allowed clients, like if you're using Postman and if you're using HTTP clients, that they don't require you to, they don't verify the cost. But if you're using a client, especially JavaScript, your request headers must match the response, the client's request header. So through that's when they'll be able to exchange cookies, and that's when the cookies will be able to save on the browser. And it was, when I was working on it today, I had to remember the cost we were at, and I was like, okay, this is really fun.
Yeah. Okay, that's good. It's a good antidote. Thanks. Other questions, comments? Okay. So here's just in pictorial form what cross-site requests look like. So you have your blog, you embed something from Facebook. In this case, you'll do it in what's called an iframe. That has consequences. I'll talk about the difference of using an iframe or not. But anyways, so you'll have this little box, and basically your browser will go over to Facebook and say, Facebook, I want you to fill in this box. Okay? Facebook has to anticipate that, so Facebook offers this functionality of filling in these boxes. And so when this request originates from this site, because it's going to Facebook, it's going to include the cookie of Facebook itself. So let's say this is my browser. I'm logged into Facebook. My Facebook cookie gets sent with this request, even though I'm not on Facebook itself. I'm on the news website. Okay, so that's fine. Then Facebook just checks its store of cookies, and it sees that that's me, so it knows who I am. And now when it gives a response back, it can give a custom response to me. So it can say that 2 of my friends like this article. When you look at the web page, it will say 3 of your friends or 0 of your friends or whatever. So this content will be personalized to you. Okay, so that's a cross-site request because the request is going across sites. It's going across from the news to Facebook, and generally this is considered a good thing. Okay, this allows different functionality. It allows mashups between websites and those kinds of things. Okay, now there are things that can go wrong with cross-site requests. Yeah.
What happens when there's like different users for the same domain? Like does it store different cookies for each user?
So cookies are stored by the browser. If you have 2 users that are using, like say me and my wife are both using my computer to log into Gmail, it doesn't know whether it's me or her. So whoever was logged in last, their cookie gets sent, and then Gmail assumes that it was whoever's cookie got sent. And then some websites will allow functionality for switching between accounts without having to log out and things like that. But yeah, you have to. It has to be two people using the same browser because cookies are browser based. Yeah. Okay. So here's one example, probably the most common example of cross-site requests sort of gone bad. So this is called cross-site request forgery. And this is the way that it works. So let's say that I can entice you to come to my website. I'm the adversary, Eve, so I'm evil. So I get you onto my website itself. Okay. Then what I can do is I can put in an iframe to any website on the internet. Okay. So for example, let's say I know that you bank with RBC. I can put in an iframe for RBC here. Okay. And then when your browser goes and fills in this box, it will go over to RBC. If I happen or you happen to be logged into RBC at this time, your cookie will go along with that request. And so RBC will just see that you're coming to RBC. It doesn't know that you're coming because you were sent there by this website. It doesn't know anything. It just sees, oh, you're coming with this cookie. It can check and it can see that you're logged in. And then it says, that's great. Okay. Now, generally, this wouldn't be a problem because so what? So the thing about an iframe is it actually isolates the two resources. So evil can't see inside the iframe, and the bank that's the code or whatever that's running in this frame can't see outside of it either. Okay, so who cares if evil can redirect you to your bank, and even though your bank thinks that you're logged in, it doesn't really matter because the two can't talk to each other anyways. Okay, so in general, this isn't a big problem. But what happened is people started redesigning how web apps work. So in particular, there was a movement for what's called REST or RESTful URLs, where let's say that you go to a website and you want to do some action. Okay, so you're looking at your balances of all your accounts and you decide, I want to move $100 from checkings to savings. Okay, now it used to be the case that you would first go to the website and it would say, okay, here's your balances. And then you'd be like, I want to transfer funds. And then the website would remember that it was you that were looking at your balance and now you want to transfer funds. And then it will ask you about how you want to transfer the funds. And then when you fill in the info and hit enter, it remembers that you were the person who just wanted to transfer, who just was looking at their inboxes. So it basically follows you all the way across. Now that's really hard to program. You have to maintain state. You have to sort of track users through this whole workflow. And so what they started doing instead is just putting the actions in the URL itself. Okay. So for example, before we look at this example, let's just do something a little simpler. So let's take Google, for example. So okay, so this won't actually show me the URL because it says my default browser. So for once in our life, the only time in our life, let's go to bing.com. Okay. Yeah, so up here you can see, for example, you maybe can't see it because it's pretty small, but you can see the query Montreal impact is here. Let's say I go down here and I'm like, I don't see the result. I want to go to the next page. Okay. When I requested this second page of results, Bing didn't remember that I was the person that was looking at the first page of results. All it saw was somebody submitted a URL and the URL had the query Montreal impact and it said, don't start at page 1, start at page result 10. I don't know where that is. It's not obvious to me, but that's somewhere built into this URL itself. Okay. And so I could have just gone directly here, or I can copy and paste this URL. I can send it to you and you can be like, okay, I'm going to open it up on my browser and then you'll go directly to the second page of results. Okay. So you don't have to type in the search and then go to the first page and then go to the second page to get to the second page. You can just go directly there. Bing doesn't care. It doesn't remember that you were on the first page. It just looks at the URL. Okay, so you move all the functionality into the URL, and then you can build a lot lighter weight web apps. You don't have to keep as much state between them. Okay, this is unlike, say, Concordia, right? If you're like go into my Concordia and do something, and I want to, copy and paste the URL and give it to you so that you can find, the course description or something like that, it's not going to work because like it just directs you to a web app, and then the web app actually changes the state. It goes from page to page to page. It's not in the URL itself. Okay. Now the problem here is, let's say, for example, I could tell my bank, so banks wouldn't be set up this simply, but this is just for illustrative purposes. Let's say that, for example, there was a URL that would transfer $100 to Eve, and I could just put that in the parameters of the URL itself. Okay. Now when I go to evil.com, evil.com redirects me to this URL. This URL was chosen by evil.com, right? They're the ones that are setting this URL. They're setting this frame to go load this resource or request this resource from bank.com. So they have full control over this URL, so they can put whatever they want in it. When the bank receives this URL, they say, well, it came with this cookie. This cookie is for Jeremy. He's logged in, and it looks like, it wants me to transfer $100 from Jeremy's account to Eve's account. And if the real banking website, like when you get to the stage where you actually want to do the transfer, if this is how it does the transfer with these URL parameters, which it probably does because now most websites are programmed this way, then this money will move. Okay, so now all I have to do is entice you to go to my URL, and all of a sudden the money moves. You just load the page and the money moves, right? And this doesn't even have to populate with anything. You don't even know the iframe's there because it's 1 pixel by 1 pixel and there's nothing inside of it. Okay. So anyway, so that's called cross-site request forgery. So this is possible because you can do cross-site requests, because cookies are stapled in to cross-site requests. And then also just a consequence of moving programming functionality into URLs as well. So that's kind of the confluence of three things. Definitely three things that didn't exist when somebody sat down and figured out what cookie policies or same origin policy should look like. So anyways, this was really popular. And once again, the reason it was so dominant is not because, like, once someone explains it to you, you're sort of like, okay, I get it. But it just took people a long time to get the right mental model of what was going on here. Okay, and that the fact that this was vulnerability, and then there were lots of websites that were made in the 90s or made in the 2000s, and so people had a heyday finding these kinds of things. They would look at like literally every function that a website that was written in the 90s ever implemented, and the website would try and fix them, but they would miss one or two, and that would be enough, and then you could exploit it. So cross-site request forgery were like the most popular attack. Now they've kind of died down again, because most people are up to speed with it. And the other thing too is that you tend to just deploy a package. So you're not hand writing the code that would use URLs like that. You're getting some package from some major software manufacturer and you're just deploying it. And it now has mitigations that are turned on. And so you get the mitigations turned on by default. So there's a bunch of different ways to mitigate it. The most common one, the one that's kind of cool, because it has to do with cookies too, is what you could do is the bank could say, hey, I'll accept URLs like this. I'll let you transfer $100 to Eve, and you can put that in the parameters. But you have to put your cookie or your session ID in the URL itself. I know it. The bank knows it. Okay. The browser knows it, but the browser will put it in the request, but it won't put it in the URL. Okay, it's not going to change the URL. It will staple the cookie into the request itself, but it's going to put it in the header field. It's not going to put it in the URL. And Eve, who writes this website, who's actually writing out this URL in this attack, Eve's the one who writes this URL out. She does not know your cookie. Okay, and so she cannot put that cookie there. And if she knew your cookie, then she could just log in and move the money anyways. Right? So she doesn't know your cookie at all. So she's not able to put this URL. But when you're interacting with the real banking website, the banking website is able to drop your cookie into every single. So basically what would happen is you download the bank website, and every time you click a button, the link to the thing that would click that button would include the cookie because you just got that from the bank. Okay? So it would rewrite all the URLs on the page so that they would include this cookie value. And then you'll just navigate around the website always having links that have your cookie value in it. You can even see in Bing, I'm not logged in, thankfully, because this is going out on the internet, but you can see that there are, like, CVID is some sort of cookie, probably, I don't know, probably stands for cookie value ID or something like that. So that's how basically it's being addressed. There's a question. Yeah.
Allow an newspaper to know the cookie from the URL?
Can you say that again?
One that allow an newspaper to know the cookie from the URL?
Good question. So the cookies are now in two places. So let's say that you are on the bank and you navigate over to this website. The cookie's in the request header, and it's actually in the request itself because that's the URL that you want to load. Okay. So first and foremost, if you're not using HTTPS, then yes. But it's no worse because they could lift it out of the header or they could lift it out of the URL. So it doesn't matter that it's in both places. But what you want to be really careful about is, let's say you're using HTTPS. HTTPS protects some things and it doesn't protect other things. So what does it protect? It does not protect the domain. So everyone sees that you're going to bank.com. As we mentioned last class, that's absolutely critical. It does protect the headers. So the cookie that's sitting in the header value is under encryption. So I can't read that off as an eavesdropper. What about the path of the file I'm going to? So let's say I'm going to a URL like this. Bank.com itself is not encrypted. What about the path that comes after? Is that encrypted or not encrypted? It is encrypted. Okay? So nobody needs to know the path except for the server at bank.com. So you only have to know bank.com to get it to the right server. The server decrypts it. Then they learn the path. And then once they learn the path, then they give you back the file that you're asking for. Yeah. So I can add that here. It's a good point, which is, so basically everything after the slash of the domain is encrypted with HTTPS. Okay, other questions? Yeah.
Can't you like really make a cookie by yourself and put it into the like URL?
Mm-hmm. Yeah, sure. Yeah, so anybody could, first off, your browser is the one that's populating the cookie field anyways. So you can always tell your browser, you could go and change the value of cookies. Like a browser might not give you the interface to do it, but there's nothing theoretically that stops you from doing it. And same with this here. So if you want to change the cookie, all that will do is it will basically treat you like you're logged out. Right? It's like you coughed up the wrong cookie value. That's fine. Then the website won't treat you like you're logged in because it doesn't recognize you.
Does it mean like we can create a cookie for like anything?
So it doesn't create a cookie. All it does is it sends an assertion of what your cookie is to the website. And then the website's going to use that to check it. So it's almost like typing in your password wrong. Or you might say, oh, here's my password. It's going across the wire. What if I flip a couple bits? That's going to change the password. So the website will receive a changed password, but it's not going to change your password on the website or anything like that. It will just be considered an invalid password. So it's the same thing here. It just will be an invalid cookie value. And that's it. Yeah.
You said like the cookies are sent to the request, but not in the URL. So what does it mean?
I forget what I said, but can you repeat? Like
the cookies are sent when we request.
That's right. Yeah.
Yeah, but the cookies are not put in the URL.
Yeah, that's right. So the browser will, if the browser sees a matching cookie, what it will do is it will drop it in the header of the request, and that's the only place it puts it, right? What would have to happen here is, in order for Eve to make this attack work, assuming that we want to have the cookie in the URL, is somehow your browser is the only one that knows your cookie. So it would somehow have to want to put the cookie in the URL, but it's not going to do that. Like, it's not programmed to do that. So.
But here at the bottom, you mentioned a cookie over there.
Yeah, so this request in this URL is chosen by Eve. So she has to write this URL out. The URL is like you request this, so you're asking for account.php, you're asking for that file, and then you're supplying some parameters to it. So this is a request. So the cookie only gets appended to the request itself. prepended in the header. But the URL does not include the cookie value. And so the bank could be set up where if it sees a URL like this that does not include the cookie value or a wrong cookie value, then it doesn't do the actual action that was asked.
Okay. So if you come down, so that is the original cookie? I mean, that is the original URL?
This is the URL that you would get if you were actually on the banking website itself. Yeah. So if you're on Eve's website, it won't. Eve doesn't know what value to put here. At best, she could guess. Yeah. But if you're browsing around on the actual banking website itself, what it will do is it will always append this cookie as a parameter to all the URLs on the website. Does that make sense?
Yeah.
Okay. Okay. Maybe it's confusing because I still have Eve here. I can change this to Bob. But. Yeah.
Like, can you say it is possible for him to replay it, and if the attacker catches this request, he can replay it like as many times as he wants?
Yeah, exactly. So let's say you're Bob and you just got paid $100 and you'd like $500. Could you replay this over and over and over? So the packet, all the things are there. So the URL is the same. The cookie is there. Like everything's there to make it work. The only problem is that TCP itself will not allow you to replay it. So what it will do, it has like a counter that gets incremented. And TLS has some replay protection. They're basically all along the stack at the network level, not at the application level. There's replay protection. So if you send the same packet twice, it will just say, "Oh, look, I got the same packet twice. I already have it, so I'll throw it away." Yeah.
Would the bank have its own transaction ID like for tracking?
Will it have a transaction ID? Yeah, probably. Yeah. So this URL is highly simplified. There would be like a million other things in it. Yeah.
So like replay won't be possible in that case.
Yeah, that's possible too. Yeah. So you could handle it. You could handle it at a lot of different levels. But anyways, even the most basic network, you just can't replay network packets and have the other person think it's a new thing. Yeah. So replay attacks work like in the 80s kind of thing, but now everything's pretty robust against them. If there was some brand new protocol that someone invented, there might be some replay attacks, but generally we don't see those anymore.
In our last class, we said like, for example, Concordia.ca, when you do a Google search within that embedded Google search, we said like it is Google nodes coming from Concordia, within Concordia. In this case, we said like the bank doesn't know it is coming from your website, that particular request.
That's right.
Is it different that in this case?
Yeah. So what would happen in Google's case, the only way that Google would know it came from Concordia, for example, is because Concordia actually put that into the iframe request. So because Concordia is cooperating with Google, Google will say, here's some code. I want you to copy and paste that into Concordia. And that code will include some identifier of Concordia itself. Yeah. So it's not, that doesn't happen automatically. So just because this request comes out of this page, by default, you actually have no idea which website it's coming from. That requires some cooperation between the two entities. So in this case, the request itself would have some, actually now that we've seen the RESTful architecture, it would have some identifiers in the URL itself that would identify Concordia as the origin of that request. Yeah.
Question.
Yeah.
If I understood correctly, that URL is very simplified in the sense that there's no identifier of the origin of the actual iframe.
Yeah. So the iframe itself, there's no way for the bank really to know that this came from evil.com. Unless evil.com wants to tell the bank. So if evil.com wants to tell the bank that's who's referring it, then it can certainly do that. But in this case, it doesn't want to. Whereas in the sort of web tracking cases, they do want to tell them.
So there will be no way to track that back?
No direct way. The bank could do things like it could say, hey, this person all of a sudden wants to transfer money, but I never saw them log in. I didn't see them land at the splash page. I didn't see them land at the page before they would type the transfer. They just went directly to the transfer. That's really weird. right? But then what evil.com would do is they would open a request to the main page, to the landing page, to the request, you know what I mean? So they would just mimic that. And so it doesn't end up being a very reliable way, but you could go back through your logs. And then the whole reason you're using this sort of RESTful architecture is because you don't want to look at those logs anyways. But anyways, that is one way you could look at, or you could look at the refer. So in this case, there would be no refer because you just jump directly to it. So anyways, there are some other ways of dealing with it, but this seems to be the most robust way, and it's the most compatible with what's already being done. And there's a handful of reasons why it's the preferred method. Yeah.
Okay, sir.
Yeah.
While you were just showing us how the URLs are displayed, why didn't it show in the Safari?
Why didn't it show in Safari? Because Safari treats Google like it's the local search engine. So it's the address bar doubles as both your search bar and as the URL bar. So like in Firefox, for example, there's a search bar and there's a URL bar, and they're different. Here it just overloads that bar with two functionalities.
It happens for everything?
No, just for Google, because I have Google set. So if Bing was set as my default, then right now it would show Montreal Impact or whatever my search query is instead of the Bing URL. Yeah, there is a way to get the Google URL. I just have to go into inspect element to pull it out. Okay, now similar to the cookie policy, there's something called the same origin policy. So that's sort of where we're going. And it looks almost the same as the cookie policy, so we'll go through it. It's more relevant to scripting. It applies to all resources. So whenever you have a website that loads resources from multiple places, and those places are called origins, so that's why the term is origin. What will happen is your browser will look at it and it will tag it with where it's coming from. Okay, and the way it tags it is, well, first off, what it's tagging is every resource. So it could be an image, it could be an iframe, it could be JavaScript, ActiveX, anything like that. It could be HTML that's inside an iframe or something like that. Okay, and the way it tags it is it tags it uniquely according to the protocol it received it. So HTTP, for example, the domain that it came from, and the port that it came over. Okay. Now, websites could change their domain. So sometimes you want things that are from different origins. You want your people's browsers to think that they are from the same origin, because then they can talk to each other. Okay. So you can override the fact that, for example, I want an origin match, not just other things from encs.concordia.ca, but any concordia.ca. So I can run set document.domain, and then that will override it. Once it's overridden, then there's a flag that gets set, and then it basically kind of ignores all the other information about the origin. So things either have the flag set or not set. We won't worry about setting the flag, so we'll just assume that the flag's excuse me, we'll just assume that the flag is never set. Okay, so for example, HTTP users.encs.concordia.ca, if the path changes, but the domain and the protocol say the same, then they're the same origin. So me and Manon, for example, we have the exact same origin if you load both of these index pages. Okay, as soon as I switch from HTTP to HTTPS, even though the domain is the same, these would be considered different origins as far as your browser is concerned. And if I change the domain at all, so instead of users.encs, let's say I go to just CISE, even if I go up a domain like just Concordia, or I go down a domain, as soon as the domain changes, it also is considered a different origin. Okay, so origins have to, if something's the same origin, it means that it exactly matches in terms of the protocol and the domain. Also the port, we're not really in the habit. I mean, you can say blah, 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 :07, and then that would send that over port 107. So we're not really in the habit of adding port names, unless if it's some like weird internal network address or something like that, but you generally don't see them. Okay. All right, so that's how you're going to determine origins. And the basic thing is, if two things come from the same origin, they can talk to each other. Okay, so for example, let's say you have two pieces of JavaScript. They're from the same origin. They can write to each other, or they can read the resources of others. Or if you have a website and you have JavaScript, the JavaScript can read the other images that are on the website and things like that. Okay, if they're from different origins, we would expect some isolation. So different origins can't read or write to other resources that are from different origins. Okay. So the question now is, how do I get multiple resources on my website? So I'm going to have a bunch of different resources from different things. And there's two ways that you're going to do it. One way is you're going to do what's called embedding. So for example, I have my website, and if I load an image, I'm probably just going to embed it directly into my website. Okay? As soon as you embed it, it's exactly like you actually just hard-coded that image in the HTML file. Okay, or it's like it copied and pasted that image into your HTML file. And so what that means is, even if it comes from a different origin, it's tagged as the same origin as the page that's embedding it. All right, and that applies to JavaScript as well. Okay, so for example, let's say I have a website, and you could just write JavaScript inline. Like you can go script, in triangle brackets, write out your JavaScript, and then close the script tag. Okay, that's clearly mine. Like it's my website. I have this script. It's in line with that actual website. That obviously belongs to me and to my origin. Okay. Similarly, maybe I don't host my code. Maybe the JavaScript file is in its separate file in the same directory. So you're looking at index.html. The JavaScript is in the same directory. Okay, so in that case, what I'm going to do is I'm going to embed it. So I'm going to say script, and the source of this script is coming from this other file that's in the same directory. Your browser will go grab that JavaScript file. It will embed it into your file. And in this case, they come from the same origin, okay, because it's just in a different directory on the exact same server. So it's clearly the same origin. And so that JavaScript can sort of govern over that page. Now let's say that I host my JavaScript on GitHub. Okay, so GitHub has the code, or maybe it's your code on GitHub, and I want to run your script on my website. Okay, now the point of running your script on my website is, let's say your script loads some images. Well, your script has to talk to my website or be able to load images onto my website. It needs to do things with my website. Okay, so the same origin policy says, when you take that script and you embed it on your website, it's just like you wrote that out by hand in line in your website. And more specifically, if it's coming from GitHub, when I embed that on my website, Java doesn't say that's a resource from GitHub. It says that's a resource from users.encs.concordia.ca. Okay? So embedded resources have the same origin as the page that's embedding them. They're assigned that. Okay. Okay. And then frames are different. So the other way I can embed things is I can load it in a frame. Okay. Now, usually you don't directly embed it. You sort of load a frame, and then the frame would load the script. But in either case, that frame is isolated from the rest of the website. Okay. So if I go to Facebook and I say, here's a frame for Facebook, Facebook loads some scripts inside of that frame. Those belong to facebook.com. The frame itself is the embedding page. So if the frame itself is from Facebook, that's the page. It can embed whatever it wants in that page. That has the origin of facebook.com. Okay? So the Facebook stuff can't talk or read or write to the page that embeds it, and vice versa. The outer page can't change or mess around with the resources that were loaded inside the Facebook's frame itself. Okay, so the two are isolated from it. Okay, so just to illustrate the differences, so if I have an inline script, let's say this is my website and it's at users.encs.concordia.ca. The script that's inline will have origin user.encs.concordia.ca. A script that I load from users.encs.concordia.ca will obviously have origin users.encs.concordia.ca. If I have a script that I embed from google.com, okay, it's assigned the origin of the page that's embedding it. Okay, so just because this comes from google.com, that just means it's being hosted remotely. It doesn't mean that's supposed to be Google's script. Okay, And so when I run that on this website, it's given users.encs.concordia as its origin. Okay, so it's just like I copied and pasted the code in line. There's no difference by remotely hosting it. Okay, now that may seem counterintuitive. It is. It caught a lot of people by, like, people early in the web, like 90s and stuff like that, didn't always realize this, and this led to a lot of attacks. You've heard of cross-site scripting, so that's the basis for that attack. But it also makes sense. The inverse doesn't make sense either. So for example, if this script ran with origin google.com, then if I can get some script and like store it on google.com, then I'll just like point you to a website like google.com. I'll kind of run my script, and then my script can go mess around with your Gmail account or whatever it is, because my script has origin google.com and your Gmail account has origin google.com. Okay, so it seems crazy that you would give the origin just because someone's remote hosting your code itself. Okay, so the converse doesn't really make sense either. So anyway, that's how it works. Conversely, if I have an iframe, the iframe is from Facebook, it's isolated. Okay, so if Facebook fills this in to say that 3 of your friends like this article, the article itself, or the scripts that are running on the article itself, it can't read out the fact that 3 of your friends like this article. Okay, it can't see inside of this frame. And conversely, whatever scripts that Facebook are running here, they can't see anything up here. Like say you have a box for Twitter and you have a box for Facebook. The Facebook box can't see how many followers you have on Twitter, and the Twitter box can't see anything about Facebook, and none of them can see anything about the articles or anything like that. Okay, so iframes are isolated from each other. They're considered different origins. So at least by default, they can't communicate. Now, sometimes you want to override that. Okay, so sometimes you want your Concordia to be able to talk to Facebook, or you want Facebook to be able to pass things back to Concordia. So you can do it one of 2 ways. Sometimes these frames, say this page is being loaded by users.encs.concordia, and this iframe is like search.concordia.ca. They're all Concordia stuff, right? But they can't talk to each other because they're not exactly the same origin. Okay, their domain's not exactly the same. So what both of them could do is they could both change their origin. So they could both use the trick that we saw up here, set document domain equal to concordia.ca. Now they actually both have the same origin, and because they have the same origin, they can talk to each other. Okay, that's one way you can do it. The other thing is there's this thing called post message that was referred to earlier, and it allows communication between 2 frames. So both parties have to authorize each other. So basically, Concordia would say, I want to be able to post message to Facebook, and Facebook would have to say, I want post message to Concordia, and then they could talk across to each other. Okay. Now, the other thing about JavaScript that we didn't explicitly say is JavaScript is very powerful. So if I have JavaScript, say, running in this pink box, say I load it from google.com and it starts running, it can mess around with this entire page. Okay, it could completely change the contents of the page. It could basically put whatever it wants there. It could start loading new resources and pulling new things into the website. If there was a password field, it could read out the characters as the person typed it into the text field. It could steal the cookie for users.encs.concordia.ca. So once you get JavaScript that's running with the same origin as this website, like, all hands are off. Like, there's nothing you can do. If you get malicious script running, it's going to trample over your entire website. It can't trample past the iframe itself. It could influence whether this iframe is loaded in the first place. Okay, so it could replace it with like a fake looking Facebook thing instead. So there are a few things it could do, but it couldn't reach into the real Facebook and say you typed your password inside the iframe, it couldn't read that out. Okay, but it can do a lot of damage. Okay, so JavaScript is kind of all powerful. And so you have to be really careful about where you're loading scripts from. Okay, if you load a script that's bad, that someone modified, then it could trample over your site. Let's say this script comes down over HTTP, right? Then the adversary could just change the script to whatever they want, and now they own your website. Okay, so that's why browsers no longer let you download JavaScript over HTTP. It has to come over HTTPS, otherwise anybody could inject anything into that, and then they could completely, trample over your entire website, or at least what's displayed to the user itself. Okay, so this technique is called cross-site scripting. Because cross-site scripting is sort of all-powerful, there are attacks that are called cross-site scripting attacks, which are basically ways of getting your bad script onto someone's website. And once you can do that, then you kind of own at least the user's experience with that website. So you're not attacking the website itself. You're attacking the user who's displaying this website. So they're subtly different. So for example, I could steal maybe this user's password, but I couldn't steal like everybody's password on user.encs.concordia.ca. So generally cross-site scripting is like a targeted attack against a specific user. Okay, and so the remaining question is how do we get malicious script onto a website? And that's sort of the driver of all the different variants of cross-site scripting attacks. Okay, so let's take a 10-minute break, and then when we come back, I'll show you a couple different ways of landing your malicious script on someone's website, so you can take it over. Okay, so let's say we want to exploit cross-site scripting. So cross-site scripting in and of itself isn't bad. Okay, it's used for lots of things. It's a way of getting JavaScript on your page that you don't want to write inline, that you want to have hosted elsewhere, or someone else writes a library and you want to run it on your website. That's obviously a good thing. So cross-site scripting in and of itself is not an attack, but it could be used for an attack. Okay, and so to use it in the context of an attack, the basic idea is that you're just going to get some malicious JavaScript. You're going to get somehow the target that you want, the website that you're targeting, to run that JavaScript. And if you can get them to run it, then that JavaScript is, like I said, sort of all-powerful over the website, and it can really change the resources and steal cookies and keystrokes and those kinds of things itself. Okay, so how do you get your malicious script into a website, like say Google's website or something like that? There's a lot of different ways. So people have dreamt up all sorts of different ways. I'll show you a couple if there's time. I'll show you some more complicated ones. So the earliest way, like in the 90s or before, was a lot of websites would have, like way back in the day, it would be so rare that someone would actually land on your website that you would have like a guest book where they could like leave a comment. And it was basically a text field. It would get posted using form post to your website. And then when the next person visited, it would actually add that to the content of the page so they would see that guest book entry. So what people would do is they would just write JavaScript in the scripting tags. That would get copy and pasted with your HTML. And when the user's browser read it, they would hit that script tag, and they wouldn't think, oh, that's content of the page. That's actually a script that I need to go run, and then they would go run it. Okay, so that's the earliest thing. Sometimes it's called persistent cross-site scripting because it's stored for that website forever, and so as long as people keep going and visiting that website, that script will run. Okay, so anyways, that was done for a while. Then people realized it, and then we went through a phase where everyone was scrubbing this out of all the different websites and going into the website and trying to find every single text field and making sure that it wasn't vulnerable. How you scrub it out is there's different techniques. The most common is that you just don't let people to post arbitrary things. In particular, if you see triangle brackets or things that look like characters that would be code as opposed to data, you just sort of disallow it. You kind of blacklist them, or you only whitelist like alphanumeric characters. There's other techniques too where you're just careful about how you store it and reflect it back to the user. In that case, you could, like, there are websites that have code, like how to program in JavaScript. You're going to have a website, it's going to display code to you that's in scripting tags, but somehow your browser knows that that's text and it doesn't execute it. So cross-site scripting also involves a certain amount of like bad programming, so your browser actually confuses data for code. So that's like in addition to actually getting your script inside of the website itself. But anyways, you're going to take another course on like network security or something like that, and you'll probably go into like all sorts of detail on all these different types of attacks. There's another one that's called reflected. And so in this case, going back to those kind of RESTful looking APIs, you might have like, say Concordia has a search function and there's a query. And so if I go to this website, it's the URL that actually triggers the search. So it's not that I went to the search and I did the search. It's just that I went to that URL. As soon as Concordia saw that URL, it says, okay, somebody wants to search for this particular query. Let me actually go and search that query. And then they'll also write something about it. So a very common thing they might say is like, we found no results for what you searched for. Okay. And how did it know what you searched for? Well, it was whatever was up in this URL itself. So it just sort of copies and pastes the search term from the URL into the body of the website. So then what people will do is they'll put a script in the URL for the search query. And then then you send that to your friend and say, you know, click on this link. They click on the link. And then what happens is Concordia will unwittingly pull this script out of the URL, embed it in the page, execute it on your friend's computer who's looking at this link, and then now it does whatever evil things it's going to do. Okay, so that's called reflected because the script comes reflected in from the URL. And once again, you need to get a bunch of ducks in a row to actually make this attack work. You have to be able to put things, weird looking characters and stuff into this query. You have to have a website that's actually going to do this, like take this thing and put it in line. And it's not going to display it in a way that the website, or rather, if you want the attack to work, it has to display it in a way that the website itself will confuse this data for actual scripts that it should execute. So it will sort of embed it flatly into the HTML itself. So anyway, that's a lot to ask of a website, but there were lots of websites that had this kind of vulnerability. And so then we went through a phase of kind of fixing reflected cross-site scripting attacks for a while. Okay. Another thing that you can do that's a little simpler is, let's say someone has a really popular JavaScript library. They put it on GitHub. Everybody uses it. If somehow you get like write permissions, or maybe you pull request something with malicious changes, and somehow it slips through and the library changes as a result, now everybody's loaded your kind of poisoned version of that library. Or if you're like, if you just mirror a library, you might change it and people might load your version because it's the top one on Google results, or it runs a little faster, or it's closer to them or something like that. Okay. So if you can poison an already existing script. The other thing is it might be in combination with another attack. So let's say you breach a server that actually is hosting a bunch of JavaScript that people are using. And then now that you breach the server, you change that JavaScript. Now you can infect not just the web server that you just breached, but you can infect a bunch of websites that are using or relying on this JavaScript as well. Okay, so that's another approach. And then the other thing is, if you ever see a script that comes down not over HTTPS, then you can just change it on the wire. Okay, you can just replace it with your favorite JavaScript file, and then that will get embedded in the page and it will run instead of the real script. As a result, browsers now block non-HTTPS scripts. Okay, you used to get, first off, it used to just work. Then we went through a phase where it would show you a warning. It would say mixed content, and it would have like a weird lock with a cross through it, kind of. But then so many websites were doing cross-site scripting where they were loading resources not over HTTP that you would just see mixed content everywhere. And then because you would see it everywhere, you would just ignore it as a user, right? That's going back to usability. You wouldn't think that maybe this website is bad because I'm seeing this particular indicator. And so now they just block it, right? And the other thing is sometimes it's too late, right? By the time you see it, yeah, they show you a warning, but like the JavaScript's already done the damage. And so who cares if you saw a warning? So anyway, this is a much more sensible approach, is to just block all non-HTTPS scripts. Okay, questions about this, cross-site scripting? Okay. All right, so if there's time, there's a few other things I'll talk about. We have actually quite a lot of time. Okay, another kind of variant of cross-site scripting that's a little more complicated, it's called self-inflicted cross-site scripting. So sometimes you go to a website, so you can get all sorts of tools that will scan a website, they'll pen test it, and they'll tell you where there's like possible cross-site scripting vulnerabilities. And so you might find that, oh, there is a cross-site scripting vulnerability, but it's like in some like administrative panel of the website. And I'm the administrator of the website, so when I log into the admin panel, I see it and that script gets executed. But when all the users of the website log in, they never see that because it's only for me. And so that's kind of useless to use. I can't weaponize that because I can only attack myself, right? Or like say like in your inbox, you could like craft some email to yourself that had like some crazy script in it. But like you couldn't give that to like someone else for some reason, okay? Like maybe you attach it to your own email and then now it's sitting in your email. I don't know what the example would be, okay? So it may seem like, oh, you can't actually do this. You can't actually attack anybody else. But guess what? No problem. You actually can do it. The way that you can do it is actually the same origin policy is going to help you do this attack, okay? So what you'll do is you'll get your victim, say Alice, to go to your evil website. So a lot of these attacks start with you having to get the victim onto a website that you control. How do you do that? Well, you could do it with social engineering. You can do it by sending a phishing email, something like that. There's lots of ways of getting people. And most people have a mental model of, yeah, if I go to a website and I download some exe from it and I run it, that's bad. But like if I just go to the website, that's not that bad, right? Like if I get a URL and I'm not sure what this is, there's no harm in just clicking it, right? If I just click it and look at the website, that's fine. You know, if I start downloading things or typing passwords into it and things like that, that's bad. But in general, if I just look at it, that's okay. Okay, so that's sort of the mental model, and that's generally actually an acceptable mental model. Is that that's what the web strives to be? Is that you're never going to get in too much trouble if you just look at something. Okay, if you interact with it, then maybe you will. But anyway, so what will happen is you'll trick Alice into going to evil.com. And in this case, what you'll do is you'll create two iframes that go to, say, the admin panel of this vulnerable website. Okay? So you'll load both of them originally to the exact same admin panel. And what you'll do that's actually really crazy is you'll log yourself in. Okay, so you're Eve and you're creating this website and Alice is actually looking at this website. But when Alice looks at the website, she actually gets redirected using cookies or whatever you want to your, you logged into this website. Okay, so Alice will never actually see this because you won't make the iframes like actually show anything to Alice. But effectively what's happening is this is loading, say, your inbox in Gmail and logged into your account, okay? Then what happens is because you've poisoned your own profile with some script, you got a cross-site script in it, then what will happen is you can use that script, for example, to log yourself out and log Alice back in. You might have to use cross-site request forgery or something like that to log Alice back in, but because Alice is browsing here, her cookies will be sent with all the requests to this particular profile. And then the other thing is that notice that 1 and 2 are the same origin. Okay, so even if this is Gmail logged into my account and the second window is Gmail logged into Alice's account, they're both Gmail. Okay, so whatever script is running on Gmail logged into my account can read all the resources of Gmail logged into Alice's account, because they're being loaded on the same page and they're coming from the same origin. Okay, so because they're in the same origin, so what you'll do is you'll basically make one window that's logged into your account running your malicious script that's going to spy on the other window. And then in the other window, what you'll do is you'll try and get the real user logged in using the fact that she's the one that's actually browsing and her cookies are being attached to all of the traffic. And then once you have her logged in, you'll exfiltrate all the data from her inbox into your other script and then send it wherever, send it back home. Okay, so once again, you need a lot of ducks in a row to make this attack work, but it's not impossible. Yeah.
Can we actually log into two accounts from the same browser to the same website?
Yeah, so good question. So no, but does it matter? So what will happen is you'll initially log in as Eve, and then the JavaScript will start running, right? And then when you log out, yeah, it would log this out if you refreshed it, but you're not refreshing it, right? And so that JavaScript just keeps running until someone refreshes it, right? It's the same if you open your inbox in one tab, then you open a new tab, you log out, you log into another account. If you go back to the original tab, it's still there because it loaded. But as soon as you click on something or do something with it, then it realizes, oh, you're not logged in anymore, right? So this script will just sit there and keep running until it tries to do something. But yeah, so you will effectively log yourself out, but it doesn't actually matter. Okay, questions about this? So this attack is kind of wacky, but anyways, it shows you that the main point of this attack is that sometimes cross-site scripting is like super simple, like you just type a script into a guest book or like post it on someone's wall on Facebook and then it runs, right? And so you laugh at that, but like that was actually the original cross-site scripting attack was on MySpace as opposed to Facebook, which was like kind of the predecessor. And so what someone did is they just, they posted a script, and it would basically, if you visited their like wall or whatever it was called in MySpace, their space, I guess, then you would run that script, and the script would automatically make you like their page and follow them or something like that. And so somebody just like got millions and millions of followers. Oh no, I think what it did is it would make you follow them, and then it would also copy the script and paste it on your own wall. So then everyone who looked at your wall would also do the same thing. And so basically it actually brought MySpace down because everybody started liking this person and posting to their wall just as soon as they would look at least one of their friends that sort of got infected. So this is considered the first kind of internet worm, and it was made by cross-site scripting. The person who did it actually, I think they actually got charged criminally for doing it. Like it was actually taken very, very seriously. They were a hacker. But yeah, anyways, that was something that ran. There was another question, I think. Yeah.
You were talking about like attacks are only visible to the attacker, like or myself.
Yeah.
Is reflected access a like type of that? Because in reflected access, if I'm stealing a cookie, it's my own cookie, like not someone else's cookie.
Yeah, exactly. So in this case, the JavaScript, if the JavaScript can steal the cookie for whoever's looking at this website, then the JavaScript can also open a connection back to evil.com, and then it can take that value and pass it back. Yeah, so once you get a script that's running, then the script can kind of do anything that it wants. Yeah. Okay, one other thing, another kind of fancier attack is called, actually this is a really lo-fi basic attack, but it's also has to do with both cross-site scripting and cross-site request forgeries. It's called clickjacking. And so the basic idea here is, let's say you go over to evil.com and evil.com embeds this Facebook box and it says, two friends liked it, and then there's a like button, okay? And so you as evil.com, you really want this user who's looking at your website to click that like button, because if they click that like button, try and draw a better like button. That does not look like a like button, but it's supposed to be. Anyways, if they click that like button, then you'll get likes on evil.com, and eventually you'll get like millions of people who like your article, okay? So the question is, why can't, this website is evil.com. The like button's sitting there right on your website. It's right on evil.com. So why can't evil.com just kind of reach down and click that button on behalf of the user? Okay, and so it can't because of the same origin policy. Okay, so the same origin policy says whatever scripting you're running here can't reach inside this iframe. Okay, so as long as this is an iframe, and Facebook won't let you not put it in an iframe, it's not going to reach down and click that button for you. Okay, but that's not to say that you can't do anything. For example, you do control this whole website, and you kind of control the real estate of this website as well. So what you could do is you can, for example, have this iframe with this like button, and then what you can do is you can kind of like superimpose an image over top of that iframe, okay? And it says, come play this really fun jackpot game. Press this win button, and then these wheels will spin, and then if you get like 4 cherries across, then you'll actually win $1,000, right? And so what's the harm of clicking that win button, right? Well, when you click the win button, what happens is it's actually transparent in terms of its click. So this is something you can do with content, with CSS files, is you can sort of make them transparent in terms of clicks. So you click on the button, but the click actually goes through that like kind of transparent image, and it clicks on the thing that's underneath it, which you can't see, which is the Facebook like button that Facebook itself populated. Okay, so what you did is you sort of hijacked the click of the person. So this is called clickjacking. So that's another attack. It's another kind of lo-fi way of trying to sidestep the fact that you can't. So cross-site request is being able to populate this field, but then same origin policy saying you can't cross over this boundary, and so you're sort of overriding it. Okay. Now browsers will do things like not allow transparent images, and there's some, or if they see them, they're treated suspiciously, or they won't let clicks go through. And there's been some responses to it. Some things like NoScript and like different extensions will warn you when they see things that look like clickjacking. But anyways, so that's how you could, for example, a lot of people had this experience for a while where, I don't know, they'd be browsing the internet, then they would go over to Facebook, and all of a sudden they had posted like some ad, you know, for like some product, and they never remember posting it, right? So like, how is it that that ad got in? And then they're like, oh my God, someone hacked my account, someone stole my password. Well, no, probably someone didn't steal your account. All that happened is you went to some shady website and you clicked on something, like one of those articles that's like, I don't know, the top 10 things that you should never tell to like whoever, and then they're like next, but then there's like 10 next buttons, and one of them's the real next button, and then the 10 of them are like advertisements that like have next. And so if you click on the wrong next button or whatever, then yeah, it will post this thing automatically to Facebook. That's the functionality of what's underneath, and then that's how you end up with this thing. And so you weren't hacked. It was you were the only one that was logged into your account, and you did actually authorize that website to post that link on your Facebook. You just didn't realize you were authorizing it because you were clicking on random things. So anyways, that was like, yeah, a couple years ago, that was like kind of all the rage, but not so much anymore. Okay, so let's think about some sort of some high-level lessons from not just the same origin policies, but policies in general. What makes policies sort of hard to get right? So we could say the same origin policy is successful. We might say it's not successful because there were all these like cross-site scripting attacks, cross-site request forgery attacks. So I don't know, like, but anyway, what made it difficult is there's a lot of like kind of moving parts. There's a lot of corner cases. So that makes it hard to get it right in the first place. Another point that I don't have written here too is that sometimes the thing that you're trying to write a policy for changes kind of under your feet. So in this case, you had policies that were written in the mid-90s, and then the web changed a lot, right? These are policies about cookies and JavaScript when the web wasn't really using cookies and JavaScript a lot. Now the web basically runs on cookies and JavaScript, right? Like every website uses it to some extent, or yeah, between that and server-side scripting. And so anyway, so these policies that from the 90s have to like kind of predict the future in terms of how people are going to use things. People want to do mashups, and they want to do all these like weird things. And so writing policies are difficult for that reason as well. Once you kind of write a policy, it's hard to change it. Okay, so you could say, well, actually, same origin policy isn't doing a good enough job. We should have better content isolation. Browsers could change it. They could change it tomorrow, but the problem is it would break so much of the web. Okay, and if it breaks the web, then that's bad. Then users are getting errors, and then they're going to uninstall your browser that has the new policy because that's the browser that's giving them a bunch of errors. And then, you know, the other browser that didn't update their policy isn't giving them errors, and so everyone will use that. Okay, so backwards compatibility is hard. You can grant, or you can sort of add new policies onto it. So that's sort of the approach that people have begun to take. So they said, well, let's define a new markup language where you can start to mark up how you want isolation to work within a website. If you have an old website, you won't have any of this markup, and so that's fine. You'll just run the old way. But if you're writing a new website today, then you can put some of this content protection in place, and then new browsers will interpret it, and it could change what the default settings are, like same origin policy, all the defaults and things like that. So that can give you more isolation or less, depending on exactly what you want to do. So there are things like that, like I forget the name of it. I think it's CSP, Content Security Protection, or something like that. So it's like in some stage of specification. It might be in browsers now. I sort of stopped paying attention to it because it was taking them forever to do it. So I don't know if it's actually working today, or I think it must be working today, but I don't know how kind of rigorous it is. But anyways, that's one way forward, is that you sort of layer new policies on top. Yeah, this is more applicable, I guess, to airport security or something like that, but it also applies to things like same origin policies, is that when policies evolve over time, and you can't go back and change the old policy, then you get this kind of patchwork of a bunch of different policies that sort of get layered on top of each other. Or someone thinks of a new corner case, then you create this new like sub policy to address just that corner case. Then someone thinks up of another corner case, and then you come up with a new policy to address that, instead of one sort of unified, very elegant policy that deals with everything. Okay, so it's hard to even if you know what that policy should look like, it's hard for compatibility reasons to just turn off the old policy one day and turn the new one on the same day. As things become a patchwork, they tend to get more complicated. Complexity can create its own problems. Okay, so the more complicated your policy gets, the better the chances are that there's some sort of escalation of privilege, or there's some sort of loophole that you can find your way through. Okay, so the more special cases and don't do this if that, and don't do this if that, the higher the chances are that you didn't actually cover everything perfectly. Okay, so sometimes simple policies are kind of they're the least ambiguous, so they leave the less room for attack. And then when you have a bunch of policies that are written by different people and they're supposed to interact, then you get into problems too of composition. And so the two policies, or sometimes different browsers will implement different policies. So same origin is pretty consistent across all browsers, but like in terms of how you handle, like say mixed content loaded over HTTPS or not HTTPS, or things like that. Like you might have different composition issues. You might have composition between what HTML is doing, what CSS is doing, what the same origin is doing. So the browser and the languages themselves. Anyways, there's other issues that can arise when you have a bunch of policies and you stack them together and you want it to work as a single unit. So anyways, that's all I have for lessons. Any questions about this? No? Okay. Any questions about the entire course? Because that's the very last thing I want to say. All right, we finished in record time, so enjoy the rest of your night. Thanks.